Good morning, dear students. Today we are going to start a next chapter, that is nothing but kinetic theory of gases. And today is our first class. Okay, so lecture number 1. Okay, in case of kinetic theory of gases, this is nothing but first lecture. Okay, so I hope you might have been remembered in second part basically. Okay, that means the second track of the physics. We had started with the concepts of solids, correct now? So after that we had discussed about fluids, correct now? And after fluids, that means basically liquids and gases part. And finally today we are going to start our discussion with gases. Okay, gases as well as what all the things will carry in ideal gas condition and remaining all concepts. So today we are going to move with the introduction part of this. Introduction to kinetic theory of gases. Now listen. We know that gases consists of large number of molecules or atoms, and these molecules are moving randomly. Correct? So we know this fact. And to start the discussion about this gases, so the behavior of gases, how gases will behave basically, to study that concepts, the major and the most important concept we got, that is nothing but what gases consists of large number of molecules. So this is nothing but a behavior of gas. How gas will behave basically. Clear? Next. And we are going to consider interatomic as well as intermolecular forces are absent in case of gases. Basically, whenever we are going to talk about gases, we will be considering ideal gas, always remember. So interatomic or intermolecular, interatomic or intermolecular force is absent or it is negligible. Clear? In case of solids, what will happen? Interatomic force is strong. Okay, in case of liquids also, some case of, that means something we will be having as interatomic or intermolecular forces. Clear? And in case of gases, no doubt in some gases we can find intermolecular force, but in generally to study kinetic theory of gases, we will be going to treat in case of ideal gas, interatomic force or intermolecular force is negligible, or this is nothing but what? Zero. Clear? Okay. So shall we move to next part? So kinetic theory gives a molecular interpretation about pressure, okay, as well as temperature, volume, these all factors. So kinetic theory gives molecular interpretation about pressure and temperature. Okay, so it gives molecular interpretation about pressure and temperature. Pressure and temperature. Clear? And this molecular interpretation, which we will understand about pressure as well as temperature, this will agree with Avogadro's law. This concept will agree with Avogadro's law or Avogadro's hypothesis. Clear? It agrees with what? Avogadro's hypothesis or Avogadro's law. Clear? Shall I erase this part? Next, this kinetic theory of gases, it will give idea about the specific heat capacities of gases. Clear? Already we had discussed number of times specific heat capacity. Correct now? So, kinetic theory of gases gives the information about or correct interpretation value of specific heat capacities. So, kinetic theory of gases, I will be writing like a KTG in short form. Kinetic theory of gases gives information about specific heat capacities. It gives information about specific heat capacities and it will explain very nicely about this specific heat capacities. Next, it relates conduction as well as viscosity with the molecular parameters. Okay, conduction and viscosity this properties like viscosity as well as conduction, these two, viscosity as well as conduction, these two parameters can be explained using very clearly about that means from molecular parameters. Clear? Okay. Next one. Macroscopic parameters like pressure, volume and temperature. Macroscopic properties. Macroscopic properties like what are the examples I can give? Like temperature, okay, or volume, okay, or pressure. These properties, okay, property like pressure, volume as well as temperature of a system which is in closed container can be explained in terms of microscopic properties like speed of molecules. These properties can be explained using microscopic properties like speed of molecules, clear, as well as momentum of the molecules. Clear? Momentum of the molecules. Clear? Shall I erase this part? Okay. Next one. This kinetic theory of gases it interconnects with the assumptions what we are assuming, assumptions basically with these assumptions what we are considering, it is relating that assumptions with the experimental results. Or in simple words I can tell it as, it is interconnecting assumptions what we are assuming. To study kinetic theory of gases, we are assuming some concepts, okay, some facts we are assuming. Those all facts what we had assumed, nowadays it has been proved experimentally. Clear? So this is the information about this point. Next, we are going to cross check experimental evidences like Brownian moment. Brownian movement of the gas. That means initially in earlier days, okay, they had just predicted the laws, but it was difficult to prove experimentally. But nowadays what happened, as science has been grown up, nowadays these all experimental evidences we are going to get for that initial what we had assumed. Clear? Shall I erase this part? So this is just a small introduction about the kinetic theory of gases. Okay. Next. Okay. Next we are going to discuss about the molecular nature of matter. Molecular nature of matter. Molecular nature of matter. Molecular nature of matter. Clear? Okay. Is it visible to you? Molecular nature of matter. One second, just be in line. Okay, I hope now it is clearly visible for you. Molecular nature of matter. So what we are going to discuss here? First of all, we know that matter, okay, in which standard you had studied about matter? Okay, so what is matter? Matter is consisting of a large number of molecules. Clear? And molecule is nothing but what? Molecule means what? It is nothing but the smallest particle. Okay, I can call it as particle, smallest particle in substance. Clear? It is the smallest particle in substance. Next, molecule exists in a free state and possesses the properties of a substance. Correct? What is the meaning of this? Molecule will exist in free state. Clear? Molecule will exist in free state. And what particle is possessing, in the same manner the molecule will also possessing. If I consider this marker, okay, as a substance, in this marker we are having molecules of this marker. If if this marker is moving with 5 meter per second, means molecule also moving with 5 meter per second, correct? No, that's why the molecules what we are having here, it will possess property of substance. Clear? It will possess the property of substance. Is this clear to you? Shall we go to next point now? Okay, shall I erase this part? Okay, now how molecules are moving, that we are going to study now. So, molecular nature of matter. Okay. Molecules will be vibrating randomly, correct? No? So if we are having one object like this, means inside this object, if this is one molecule, means this molecule will be vibrating like this. Clear? So this is nothing but explanation of this statement. So molecules will be vibrating randomly in their desired direction. Okay, molecules will move randomly in their desired direction, and this is a rapid process, very fast process. Clear? Process is rapid process. Rapid means very fast process, quick process. Very quickly molecules are vibrating like this. Next, in our previous classes also we had discussed this point. This point is nothing but, if temperature is increased, means, come on, if temperature is increased, then what will happen? If temperature is increased, means velocity increases. Velocity with which molecules are earlier moving, they will be start moving with higher amplitude. Clear? Shall I erase this part? Just cross check what all the points we had covered. Okay, now we are going to discuss about some specialization points in case of solids, in case of liquids, as well as in case of gases. Clear? Okay, listen. Statements or important points. Okay, listen. Molecules in solid substance, basically. Molecules in solid substance will be tightly packed, correct? No, this one we had already studied. Clear? And now next, intermolecular force is strong. Intermolecular force will be strong in case of what? Solids. Now these molecules will not move freely. Molecules will not move freely. Clear? Molecules will be not moving freely. Next, these molecules will be vibrating along their mean positions. Clear? Mean position means if here initial molecule was there, it will vibrate in this manner, again this manner. This is nothing but, this position is nothing but what? Mean position. And solids will be having definite shape. Clear? These will be having what? Definite shape as well as size. So these are the points which are related with what? Solids basically. Okay. Shall we go for next part? That means in case of liquid, what all the things we are having. Okay. Now, in case of liquid, in case of what? Liquid. So what all the things we are going to discuss in liquid? Listen. In liquid, molecules will be not rigid. Molecules will be not rigidly packed as in case of what? Solids. Molecules will be not rigidly packed as in case of what? As in case of solids. So in liquid what will happen? Molecules will not be rigidly packed as in case of what? Solids. But there is some packing fraction like that. Okay, molecules will be packed but not very tightly packed in as in case of what? Solids. Next, due to this above statement what we had discussed, okay, intermolecular force of attraction is weaker in case of liquids. Intermolecular force is weaker in case of liquids. Clear? Due to this above statement only we had concluded that next statement. Therefore, liquids will be having what? Definite volume. These will be having what? Definite volume but not shape. Okay. So this is the case of what? Liquids. Are you getting? Shall we go to next part? Next part is related to what? Gases. Shall I erase this part? Okay. Now listen. In case of gases, what all the things will be there? Now, in case of gases, so now in case of gases, what all the things will be there? Now here in case of gases, what will be there? Molecules will be very far apart. That means molecules in case of gases, they will be very far from each other. Correct, no? Okay. Now next. Interatomic as well as intermolecular forces. Interatomic, okay, as well as intermolecular forces is negligible in case of gases. Next, these molecules in case of gases, these molecules will be moving in their desired direction. Moving in what? Desired direction. Clear? These gaseous molecules, first point, they will be far from each other, okay, and as they are far from each other, interatomic or intermolecular forces will be absent over there, okay, value will be almost negligible. Next, these molecules will be having the freedom to move anywhere in the space. Therefore, what we can conclude from all these three statements, gases will be not having fixed volume. I mean, these gases will be not having fixed volume. These will be not having fixed shape. These will be not having fixed shape. Clear? Volume is also not fixed, as well as shape is also not fixed. Next, these gas molecules will travel in straight line, but anywhere if they collide, it means direction will be changing. Okay, just a common sense. Next, average distance between two collisions is known as mean free path. Mean free path, and it has been denoted by lambda. Clear? These are all the statements which are related to gases. Okay, so molecules will be, first point is nothing but molecules will be very far from each other. Okay, and interatomic intermolecular forces value will be absent here, that means negligible. Next, these molecules will move in a desired direction, basically in straight line. Okay, and these molecules will be not having a fixed volume, that means gas, not gas molecules, in totally gas will be not having fixed volume, as well as gas will be not having fixed shape. And next, these molecules will travel in a straight line, and the average distance between two successive collisions is nothing but what? Mean free path. So this is the introduction part about a kinetic theory of gases. So please keep studying, or don't waste your time. And in next class we'll be going to discuss what do we mean by ideal gas, okay, and how we are going to derive expression of that ideal gas. That means equation for ideal gas. In previous classes we have discussed, no, ideal gas equation, PV is equal to, very nicely you will tell me, that is nothing but nRT. So this expression how we got, that we are going to cross check in our next class. And some postulates are there, that means assumptions those assumptions to study kinetic theory of gases also we'll be discussing in our next class. So keep studying. Thank you.